Hi y'all, this is Notes 49. For my on-track students, this is extra credit. For honors, this is required. So what we're doing here is we're solving exponential equations with logs. So solving exponential equations means that we're looking for something that we can put in x to make this true. So if I'm just trying to think about what x is, I know that 4 squared is 16. So I know that whatever 4 to the x is, whatever x is, if it's going to be 15, it needs to be just a little bit smaller than 2. But there's no number that I know right off the bat. So I'm going to use a log to help me solve this problem. So I'm going to convert it to log form, which is log like that. My base is 4. I'm going to flip around to get to my x. So 15 equals x. From there, I'm going to type into my calculator. Remember that just like we learned yesterday, we can type this straight in our calculator with that log base thing where they give us the log and then they have like the little blocks to fill in. Or I can do log of 15 over log of 4. The log of the top one over the log of the bottom one. And that's going to give me what my x is. So in this case, I'm going to type in log of 15 divided by log of 4 in my calculator, and I'm going to get 1 point, I have log 15 divided by log 4, and I'm going to get 1.953. So I have 1.953445298. And from here on out, I'm going to use the first 3 decimal places. So I have 1, 2, 3 decimals, and when I look at the fourth one, that doesn't change it. So I know that x is equal to 1.953. If I plug that back in my calculator, I can see that 4 to the power of 1.953 is equal to 15. That checks out, so I know that this is the correct answer here. To get this one started, I'm going to do the exact same thing, 2 to the 20. So I'm going to put it in log form, base 2, 20 equals x. Go ahead and solve that on your calculator. You're trying to find out what x equals here and what x equals here. Go ahead and pause now and solve these 2 problems. We'll be back in a second. So for this next problem, we can see that the exponent is not alone. So we will need to make sure that the exponent term is isolated first. So we want this to be by itself. Right now I see that there's a plus 4. So I'm going to subtract 4 on both sides. That's going to leave me with 19 to the x power equals 31. Now I can see that the exponent is alone. So I'll go ahead and take the 19, whip it around. So I've got log base 19 of 31 equals x. Go to my calculator. Log 31 divided by log 19, I'm going to get 1.166 equals x. And I know that that is my solution. The same is true for this next one. I see that this is what I want to be by itself, so I'm going to subtract 4 on both sides. I get 5 equals 8 to the 4x. From there, I know that I'm going to start with my base, so log base 8. To go around the equal sign and back. So log base 8 of 5 equals 4x. I'm going to do in my calculator log 5 divided by log 8. I get 0.774 equals 4x. I'm going to divide by 4 on both sides. That means that I'm going to get x equals 0.193. Right, that's what I have in my calculator there. For this last one, it is not super different, but it can be kind of tricky. I see that I want to get this by itself. I see the division. The opposite of division is multiplication. So I'm going to multiply both sides by 4. So I get 40 equals 5 to the 2x. From there, I'm going to put it in log form. So start with my base, log base 5, go around the 40 and back to the 2x. 40 equals 2x. Do log 40 divided by log 5. My calculator is 2.292 equals 2x. Divide by 2. X equals 1.4 1.46. I'm sorry, 1.146. All right, 1.146 as my answer. So first things first, we learned about using the loop-de-loop, right? So we use the loop-de-loop to put a log in, and then we then learned about isolating the expression. From there, we can see that this just steps up one more trick. So we're going to solve after the loop-de-loop, which we've already done. So start with my base, log 5 to the 45 equals 2x, just like that. Take this one, put it in your calculator. I know that you could do that. Go ahead and finish this problem out. And we'll take a look at this one in a second. Go ahead and pause your video now and finish this problem. You should get x equals a number. For the next one, I'm going to put it in log format again. So I have log base 5. Around the equal sign is 8 equals 4x minus 2, that whole thing. I'm going to do in my calculator log 8 divided by log 5 gives me 1.292 equals 4x minus 2. From here I can just solve normally. So add 2 on both sides. You get 3.292 equals 4x. Divide by 4. We get x equals 0.823 as my answer. Go ahead and pause your video right now and take a stab at solving that one. All right, one final one here. So the directions here say write your answer in simplest form using integers, fractions, and common logs. So that means that we will not be using decimals. All right, so we're going to use only the logs that give us. So for this one, I'm going to start with my base. I have base log 5. And I'm going to go around the equal sign and back. So 2 equals x. For this one, my common log is only allowed to be my regular log. So I'm going to remember from yesterday that this is the log of 2 over the log of 5. And that has my log with base 10 in it. That's what the common log is right there. And so I have base 10 and base 10, and it's a fraction. So this is allowed to be my answer. Right? Let's try a slightly trickier one. So here I see my base is 7. So I'm going to do log base 7 around the equal sign and back. So 9 equals 3x plus 4. I remember that this is log of 9 over log of 7 equals 3x plus 4. Normally I would type that in my calculator, but because they don't want any decimals, I'm going to just start to subtract 4 on both sides. So I have log 9 over log 7 minus 4 equals 3x. And then in order to get x by itself, I need to divide by 3. So I'm going to divide by 3 on all of the pieces. Notice that when I divide by 3, it means that I'm putting a division sign on the bottom of a fraction. So I'm going to end up with log 9 over 3 log 7 minus 4 over 3 equals x. So I'd say that this is my answer. If I wanted a decimal, I could type all that in at one time. Right, but IXL on the last part is going to ask for these directions where we're writing it in simplest form. Finally, let's just see that one more time. So we have the base is log 5. Go around the equal sign and come back. 3 equals x. I do the top one, log 3 over log 5 equals x. And that would be my answer there. That's it today, guys. Thanks.